So today's lesson, we're talking about loops. Loops is a structure that we use in programming to loop over a certain sequence X amount of times. So given a number, example, if we want to say print hello playground 3 times, we could use a loop, as opposed to saying, for example, print string. Print string will print hello playground. It will print it once. Let me, foundation, try this again. Okay, so right here we have print playground printing once. Okay, hello playground, does everybody have that? If you have a UI kit issue, I changed my import to foundation. We spoke about foundation earlier. We will get into foundation really broadly, really big later, more general speaking. But foundation basically has print function. It has arrays, it has networking classes and APIs. Foundation is, as the name says, the foundation of Swift. Okay? So make sure you have import foundation there if your playgrounds is breaking like mine did earlier. So I changed UI kit, which is user interface, to foundation. Everybody with me? Okay. So at this point, you should be able to say print string, and it prints hello playground once, correct? If I want to say print hello playground multiple times, one way I could do it, for example, if I want to print it 5 times, I could print it 5 times, correct? Here it says hello playground, hello playground, hello playground, hello playground. Everybody with me? You could imagine you have a task to do, you write some code for the computer. This becomes very verbose, very bug prone, right? I could have bugs here where I have, instead of print string, have something else, right? So it's very error prone. Everybody with me? So Swift, like all the programming languages, have a way to go over a sequence X amount of times using a loop, okay? The first loop we will see, hello? Oh, sorry. The first loop we'll see is the for loop. I will create some comments to make the heading stand out better here. So we're talking about the for in loop. Yes? Okay. The for in loop, what does the syntax look like? So the for keyword is used. So for is the keyword that we use for the for in loop. You start out by specifying it's a for loop. For is the keyword. We've seen many keywords before. For here, I will say index or number. Number is a variable. You do not specify var. The compiler infers the type based on the sequence. When I say the sequence, I'm referring to for number in, for example, 1 exclusively to 10. This is exclusive, or rather inclusive, sorry, inclusive. So inclusively prints 1 to 10, okay? Inclusively means print everything from 1, including 10, okay? We saw ranges earlier on Friday. So the 3 dots here is a range. Let's see what the range looks like again. I will copy this, and let's review ranges a little bit. So here we have a range. We said we have close range. And what? What else? Close range and? Close range and? Half open, right? Okay. Let's just do this. Okay. Excellent. So an example of a range could be, so we have a closed range here, 1 to 10. So here it includes everything from 1 and including 10, right? So this is inclusive. There's range. And we also saw half range, where we said 1 dot dot, 2 dots, the less than sign, and 10. Does that include 10? No, right? This does not include 10. Less than 10 does not include 10. Everybody with me? So it will say 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 10. Okay? So here, excluding, exclusive. Okay, so that's a basic review for what ranges look like. We'll use ranges more when we're doing the for loop. Very typical example on line 22, we're saying for number. Number is a variable. We do not say var number. We do not say var number. Swift implicitly knows number is a type integer. How does it know that? It looks at the sequence. This is a sequence. It looks at the sequence that we're going over, and it's like, hey, okay, this is a number sequence. This is integers. So Swift implicitly infers number to be type int. How can we verify that? We could option click. If we option click on number, what type is number? Integer. So far, so good? Okay. So that's the power of the for fast enumeration here. If you're coming from C, there's a different construct or way to write a for loop. But this is the modern way to write a for loop. For number could be anything. I could say for I, this is valid. I is also valid. I is also of type int. Again, it's a variable. You could name it whatever you want. But typically, you want to name it something that makes sense to that exact construct that you're doing. Those are numbers. It's a number. I could say num. Okay? So for num in 1 to 10, I want to go ahead and print what num is. Okay? So if I go ahead and play my playground on 25, at this point, we should see 1, 2, 3, 4, 5, up to 10 get printed. Correct? Everybody? So that's a for loop going over a sequence from 1 to 10 times. Okay? As opposed to doing earlier what we did here by saying, go ahead and print the string 5 times. Which one is more efficient? The for loop, correct? Okay. For loop, 3 sentences, including the open and close bracket, and we're done. Okay? I want to show us something else I haven't last week. So the print statement is a function, correct? We agree it's a function? Okay, the print statement is a function. As we see in our playgrounds here, right? It prints this number 10 times. In our console, each number is on a separate line. We have 1 on a separate line, 2 on a separate line, right? Because print, at the end of print, has an invisible end line that we don't see. So at the end of every statement, it goes to the next line, the new line, okay? This is being used, a Terminator, we'll see later when we talk about functions, but I want to show you guys now what that looks like. We could override what the print function does by providing it a Terminator. So, not Arnold Schwarzenegger, but the Terminator, right now, the default is a new line. So let's just put some notes here. So print default Terminator is the new line character. right? So the print function, the default terminator is a new line. \n is a character for a new line. We'll go ahead, we'll override that for the print to look different. Right now, it's staggered. It's like a stack, right? 1, 2, 3 on top of the other, like a plate, like a stack of plates, right? Let's go ahead and use the terminator. So the terminator, you specify using the terminator word, colon, and in in quotes, you put what character you want. In our case, we just want a space. So in the quotes, we put the space, and if you run the playground again, right, it's a different outcome. Do we see that? So now we overrode the terminator new line, and we have everything printed on the same line. Everybody sees that? So that comes in very handy. You may see it in your lab, you may not. You may want to use it yourself, but it's very handy to know what the terminator does. And we'll talk more about default parameters, but for now you could just put a default parameter here, but we'll talk more about default parameters when we talk about functions. So default parameter. Yes. The terminator is the last character in the print function. So if I do not say I want a terminator, by default it goes to a new line. When it prints something, it goes to a new line for the next item. Earlier, let's remove it for us to get some more context here. So if I do not have a terminator, and I go ahead and I run my playgrounds, instead of all the numbers being printed on one line, each print, every time it goes through the loop, it prints on a new line. That for loop basically goes through the sequence 10 times. Do we agree? This statement goes through 10 times. So each time, it creates a new line, meaning I enter 1, I go to a new line, 2, a new line, 3, new line. If you want to change that behavior, you have to use the keyword terminator. Yeah, go ahead. It moves that, it replaces that, so it replaces default parameter is new line, right? We said here. So the default parameter is the new line character, right? And we replace with a space. So now you can put anything. Go ahead, experiment, put anything in the character and see what happens. Put a dash, put a comma, and run your playground and see how it changes. I heard feedback. That's great. All right. You could even put emojis in there if you want to be fancy. Yes, sir. Yes.
Yes, can you please go over the accounts for the loop when you're doing Hello Playground so many times? Because I didn't get to really see how you did that, the Hello Playground.
Oh, yes. So Tiffany's question was, where's Hello Playgrounds coming from? So earlier when we introduced loops, we printed Hello Playground 5 times to model why we use loops, right?
So
because
we don't want to have to print it 5 times.
not like this. We'll see how to do it using a for loop. Okay?
So
That's just to show the way, if we do not know for loops or we didn't have for loops, this will be the way, exactly. Explicitly write each line, yes. Okay, very good. Okay, so going back down here, were we able to experiment with our own terminators? All right, fun times. Yes?
you see the skull in the end? Is there a way to not?
Whoa, violence. To not have it come up by just not having it.
No, I mean like the last skull after 10.
Oh, because it needs, after each number, it needs a terminator. Everybody with me? So Tanya's question was, hey, how can we explicitly do not have a terminator? We need a terminator.
No, I mean like.
This last one needs a terminator. This one needs a terminator because every number has a terminator. Every print statement, every print function requires a terminator. whether you provide one by yourself, default one, or the new line character. Okay? If you want to not have the skull appear, we'll see how to do that differently later. Okay? You could have an array and say if it's the last number, don't add it. Okay? Actually, you could probably do it here too, right? Like if 10 Terminator should be something else. Okay? Actually, let's do it. Let's see how we get to that. So everybody got Tanya's question? She doesn't want to have the skull appear on the last, right after number 10. Everybody with me? Okay. So let's see what that looks like. We could use an if statement there. So if, what should we write? What should we write here? If num is greater than 9. Okay, that's valid. Help Chelsea, guys. Chelsea is somewhere here. She got us something. If num is greater than 9.
If you do the backslash n.
Okay. So what? How? Talk to me. What's the code?
So if num greater than 9,
Print.
no.
Print num. Terminator. Right? Now, we're missing a case here. Right? So if it's greater than 9, Terminator is nothing. Else, we could just put our statement up here, correct? The skull. We could put the skull down here. We'll go over the code, but now we're using everything we've seen so far. So let me get my skull. And let's see what that looks like. Right? So our skull is gone. But we need to fix our annotations and our comments. So Tanya's question was, she wants to get rid of the skull after the 10, right? So we are able to use our if statements that we learned last week to do exactly that. Like, hey, I do not want to have the skull if the number is greater than 9. Okay? So in that case, we use an if-else statement.
What would you like to send?
Money. So if the number is greater than 9, which implies 10, my Terminator should not be a skull, right, on line 28. But any other number include the Terminator of the skull. Everybody with me? Okay. Thank you, Tanya. This gives us more use cases here. But now let's fix our comments. So default, all that is still valid. That's good. We are good. Okay, so that's the for loop in a nutshell. It gets more complex as we keep going through the lesson. Any questions? Yes.
So I have another code block after the
After the for loop, you have more code
I have another code.
outside here.
Yeah, it prints my number and the Terminator, and it's still like it prints my first result and the other code. So how does that make it?
Oh, you want to break the Terminator?
Yeah.
Okay, good question. So Stephanie now, the print, she wants to break the Terminator. You could put a print, just put a print, empty parens, and that should work. So go ahead and put a print. That creates a new line. So a new line, as we said earlier, print, open parens, close parens, gives you a new line. Okay? All right, great. Let us keep going. All right. Do I have my header? No, I don't. Let me get my header. So next topic, we'll take a preview of what arrays look like to see how functional a loop is. So here, just preview array. Preview using loops with arrays. Cool. Okay. Again, we saw arrays briefly in JavaScript, but in Swift, arrays is also very similar to JavaScript. Here we'll just create an array called pursuit stacks. Don't worry about arrays too much. We'll come back to arrays. But we have a variable, we have a constant. It's called pursuit stacks. Open square bracket, close square bracket. Starts our array, our array declaration. Now we're initializing our array with some strings. First string, we have iOS, comma, we have web, comma, we have Android, right? So that's an array of strings. How do we know it's an array of strings? It looks like an array of strings from looking at it. We could also ask the compiler what type of data type is that by option clicking. So option click on pursuit stacks. What do we see? We see open square bracket, string, close square bracket, correct? Open square bracket, close square bracket implies an array. The type inside of it is saying array of type string. That's how you read it. This is an array of type string. I could have an array of type integer, array of type Boolean, my array of my custom type. Okay, all the types we've seen, we could have arrays of those types. We're not going to get too much into arrays. I just want to show you briefly what arrays are. So we could loop, so we could go over the contents of our array. Go ahead.
I was getting the four number in at the for some strange reason, it was working before when I did four numbers or four num and 1 2 10 print right?
Okay.
And then I added in the if else statement if none is less than 9.
In that case, we have greater than 9 because Tanya didn't want to see a skull after her 10.
Oh, you know what? I figured it out. I didn't add. Oh no, it's not me. No, I didn't figure it out. So I did print, right?
Are you getting an error or?
It's telling me that like I wanted to take the comma off of the 10. I didn't put skull, I put comma.
Okay.
I wanted to take the comma off of the 10. So I said if none is greater than 9, then print and none, comma, Terminator. But it's not.
Do you have the else statement adding your comma? And make sure you run the playground after the fact if it's on manual. Okay, cool. So let's preview our arrays again. So we have an array of strings. We all agree? And our array denotation, let me put some comments here. So arrays, array declaration. Actually, let's remove that and just put a note here at the top saying array of strings. Right? We could also type annotate arrays, right? Here I could say explicitly it's an array of type string. Right? I could type annotate my array as well. But as we've seen before, implicitly, the compiler knows this is an array of strings, okay? So there's no reason to have type annotation here, but I'm showing you could also type annotate. So if you ask a question, type annotate an array of strings, this would be the way to go.
Would, like, in the real world, would they prefer it like that, or?
In the real world, as far as like coding style goes, this is the way to go, right? Type inference, right? This is type inference. The compiler knows already what type it is. If there's some ambiguity with the type, then you want to explicitly do type annotation, as we saw with character and we saw with float. Everybody remember? Right? Because the float, the compiler thought it was a double, but we wanted to have a float, so we explicitly type annotated that to a type float. Okay? But in that case, the compiler sees a string, it knows that's an array of strings, it's fine there. Cool? Excellent. So, great. But again, we'll come back to arrays here briefly. Okay, if I want to print all the values of my array, the way I do it using a for loop, so I would say for, right? Again, I could have any name here. I could say pursuit stack in pursuit stacks, right? So that here, after the for, is the variable name. immediately after the for keyword is the variable name. This name could be anything. I could say pursuit class, for example. I could name it anything, same as a variable. The pursuit stacks here is the array. That's our array here on line 40. That's the array I want to go through. You could only use a for loop on sequences, collections, right? You can't use a for on an int, right? An int is not a collection. A collection is a collection of items. Here, array has a collection of strings. Everybody with me? You could only use for loop on collections of items, okay? You have a bucket of items, you could go through them using a for loop. In that case, we have our pursuit stacks. Now, we could go to line 42 and simply say print pursuit. Well, let's use some type annotation. Let's use everything we know. So I'll say pursuit class is. Here I'm using type annotation to say what I'm printing out, the value of it. So pursuit class is pursuit class, right? So I'm going through my array based on how many items I have in the array. How many items do I have in that array? How many items? 3, correct? So I have 3 items in that array. I'm looping over it 3 times. So I'm expected to see pursuit class is 3 times in the console. So go ahead and run our playground. And now I have pursuit class is iOS, pursuit class is web, pursuit class is Android, right? That's the power of a for loop. So I'm using a for loop with string interpolation here. Printing using string interpolation. Right? And we have 3 items. Yes?
I have always confused about this variable because for pursuit class. Usually it would be assigned some.
Exactly. Good. I like that you brought that up. So Yulia is saying she's confused by for pursuit class, right? Because usually we use the keyword var or let. Everybody with me? But here with that for statement, Yulia, we do not say var. We do not say let equal. Implicitly, the compiler knows what type it is. This is the syntax we use. We say for variable in collection, go ahead and execute the loop. Let's see what that looks like. So let's do a next example. So let's create fellows here. Also an array. I'll have Tiffany. I'll have Yulia. I'll have Joshua. I'll have Matri, right? How many items do we have in the array? What type of array is it? Array of strings, correct? Okay, great. So now I want to loop over. When I say loop over, I want to go over I want to traverse. I want to walk. I want to print every fellow name in my array of fellows. Everybody with me? So dot doesn't come in, right? Because we'll use the same syntax we use on 41. We'll create a variable called fellow. We'll say for fellow, in fellows, print fellow. Yulia?
It will just show all the.
Exactly. It's going to go through the entire array. If you want to pick one of your fellows, your favorite fellow is Joshua, you could say if Joshua print. In that case, the rest of the class might not see the same, right? So we want to pick all of them, correct? But yes, you could pick individually. You could write if statements. So Zara's question, can I do if else? Yes, we could do if else as we saw in the for loop. I could say if Joshua, add 3 to Joshua. Joshua 3. I could do that, right? You could add statements, all the statements we've learned from day one in Swift, you could compound them together. You could add them together. In my for loop, I could have an if else, okay? So let's go ahead and print it. Actually, somebody come up and print it for me, please. Let's see. Eddie, come. I want to basically print all the fellow names using a for loop. Give it up for Eddie. So Eddie will begin using the for keyword.
Okay. For fellow.
He will use any variable name of his choosing. Choose a variable name that makes sense to the context. So he uses for fellow. Fellow is the variable name. In is the keyword in the collection. Fellows.
And fellows, you want to print the fellow.
Use string interpolation to give us a meaningful
Okay.
sentence there.
Okay.
So the fellow name is.
Okay. Fellow.
And go ahead and run the playground.
Okay.
Thank you, sir. Give it up for Eddie. So here we have 4 fellows. The names are printed with the statement, the fellow name is Tiffany. Everybody with me? So the variable name is up to you what you choose here. I could simply say I, but I doesn't mean anything, right? What does I mean? By somebody reading the code, they're like, what's I? What do you mean by I in that context? Give the variable a meaningful name. Fellow is perfect. A fellow is singular, okay? Fellow is singular. Fellows is plural. When you name your arrays, we'll talk about arrays more. When you name your arrays, please make them plural. Fellow doesn't imply it's an array. Fellow implies one, correct? Fellows, when you read them, implies many fellows. Okay? Awesome. Yes, sir. Oh, like an if statement, you mean?
Yeah.
Okay.
How that would work.
Okay. So Matt and Zara were asking about adding like an if-else block inside here. For example, the fellow name is, that's great. So let's add an if statement. So if fellow, we're comparing something. We saw comparisons, right? So everything we're learning is building up so that we could write meaningful programming apps and programming constructs, right? So we saw the comparison. Now we could compare something. We're looking for something. For example, I'm looking for Joshua. So if fellow equal to Joshua, right? We want to do something else. We want to say if fellow equals to Joshua, then print Joshua is awesome, or fellow, rather. Right? Else, print fellow right? So if the fellow is Joshua, go ahead and print Joshua is awesome. Else, fellow is awesome too. We could do that. We could add if-else statements inside our for loop. Yes, Christian. Oh, sorry. Ahad. Christian. Ahad. Yes.
I had a question. You use FML statements in the photos. Can you use switch statements as well?
You could use switch statements if you want to switch on something. If you have an array of weathers, right, like an array of degrees or temperatures, if you could use a switch statement there as well. We could also do that, right? So we have an array of temperatures for the week, for example. If it's in case 75, you could do something. So whatever we did on Friday, you could also add it here with a switch statement. Does everybody see that? We'll make an example of that, and then we'll go to the while loop. So for now, let's go ahead and print on 55. Right? So here, let's look for Joshua. Let's look for Joshua. So here, Joshua gets, Josh is awesome. Other fellows get awesome too. Everybody sees that? Does that answer your question, Sarah? Right? And Matt? All right, cool. We'll do one more where we use a switch statement that Ahad is bringing up, right? We could have a switch statement in our for loop as well. So here, let's create an array of temperatures. That'll give us a chance to see a different array, right? So let me actually pull up real. Oh, yeah, let me fix that. Okay, so here we have temperatures. And Monday, we have 69. Tuesday, we have 75. Wednesday, we have a whopping 87. Catch me at the beach. Thursday, we have 64. Friday, we have 64. Then we have 61. That's actual weather, by the way. I'm not making that up. So this is that's actual weather for the week. Yes. So what type of array is this? Array of ints, right? Array of integers. Do we see that? This is an int. 69 is an int, correct? 64 is an int, right? The compiler infers, hey, you have an array of ints. Okay? Again, we'll talk more about arrays, but this gives us more context with our for statements. So the question was by Ahad, can we have a switch statement inside our for loop? Yes, we can. So here we have for temp in temperatures, right? We could have a switch on temp. So here we're switching on temp, right? We switched on many types on Friday. Here we are switching on temp. Temp is what type? An int, right? So we could have a case here. We could say case. We're not going to go through too many cases here. I'm just going to look for my ideal case here. So case 87. I'll just hard code that number in. Print. Catch me at the beach. Right? And default, which we need, we'll say print just another day. Okay, so here, anything 87 and above, catch me at the beach, right? So I could have 87, I could have 99, anything 87 and above, catch me at the beach. right? That's what the 3 dots implies here in that switch statement, on the case statement. So here we have a switch inside of a for loop. Okay? Cool?
Now, can you please go up to this
Go up to the first array we had.
one?
Let me close the console. That might be better. What line?
I haven't even been to look at temperatures because I'm still,
You on fellows?
yeah.
Okay.
For mine, all right, so I did let fellows go, what you.
Let fellows. Our fellows is up here.
Right. And it worked, where I put, for fellow and fellows, friends, and I said fellow is awesome, right? Else, friends, son. No, I just left it at that. And I did an else statement afterward. So I did, all right, so I said for fellow and fellows, friends, fellow is awesome. Then afterward, I did.
We changed it. A question was brought up for fellow in fellows, the for loop, right? Somebody asked, can we have an if else in there? Yes, we could. So we removed the print statement we had before, and we added an if else. So the if said, if fellow equal to Joshua, go ahead and print fellow is awesome. Else, fellow is awesome too.
Okay, so because I have a print statement.
Remove that print statement. That's the first thing we had until the question was brought up forward about the if else.
Okay, but now it's saying you will value fellow is number U.
Because you never use string interpolation to print it. So if you never use the fellow variable, it will tell you, the compiler is smart enough to say, hey, you never use this variable, either use it or use an underscore, which we'll see later. We'll see what that means, your question. Yes?
Say if you wanted to just print one of the statements, like you said,
So if we, in the fellows,
no, in the next one.
in the temperature?
Yeah, like
Okay.
87 and above.
Yeah, 1 second. Everybody okay with fellows? I'm gonna scroll down. Okay, so temperatures, Andrea?
If it's, you said like the case is 87 and
I
above.
could have more cases, yes.
But how could you just print it? Because it's only 187, there's nothing above that.
There's nothing above that, but I could change this. I could add an X temperature here, right? I could add 100. So how many times will that get printed?
Why?
Twice. Does that answer your question?
But how would like, I guess it's not related, but how would I like pick out the temperature and just print that?
In that case, you probably have a range, right? Like if it's, like we did on Friday, if it's less than 45, maybe grab your gloves, right? If it's between 75 and 80, that's my perfect weather. So you could have different ranges in that switch. So that switch was just to portray how we could have a switch statement inside the for. But anything you do in a switch, you could do here. Cool? Mr. Matt. So the dot is from 87 inclusively, from 87 to infinity. Right? The dot here, everybody. So include 87 and beyond. And greater. Okay? Everybody with me? So 87, 88, 89, and so forth to infinity. There's a max you'll get to in that max, whatever that is. But infinity, in quotes, right? Whatever that max integer is. Very good. Any other questions? Okay. Tiffany was bringing up a question or an observation earlier. The compiler gave her a warning. She had a variable, and the compiler said, hey, you're not using that variable. Let's see what that looks like, which is also very important. So let's say we have a message. Happy Monday, iOS 6.3. We want to go ahead and we want to print this message X amount of times, whatever amount of times we want to print that message. We want to print that message. We want to use a for loop to print that message. We'll go ahead and we'll type in a for loop. So for underscore here, we'll come back to what the underscore means. We'll use some range like we saw earlier. So the for underscore here says, I am not interested in the variable name. It ignores the variable name. Remember earlier when we had num here, everybody? We had num and we said, go ahead and print num. Actually, let me comment that out so we could see that warning. So do we see what the compiler says before we use num? It says, immutable value num was never used. Immutable value num was never used. Consider replacing it with an underscore or removing it. Right? We declared num here, but we never used it. So the compiler is like, hey, dude, if you're not using it, put an underscore, which we'll do. Yes? Actually, before we do it, let's just print it out first to get back some context, and then questions are going to come up. So we have our print statement here. It goes ahead and prints 0, 1, 2, 3, 4. It prints 5 times, correct? Everybody has that in the console? Yes? Tiffany, what's your question?
My question was going to be that when you put something for, even if it's switch or in the case or whatever, when it's in an array, it's going to compare whatever the case is for each.
You're talking about our switch statement of
No, just for each one. For example, like for the temperatures, I put like let's say the case is, well, we put 87. So for 87 of this, we're going to put it twice because there are only 2 cases.
there's 2 temperatures above,
Right.
yeah.
Now I put 8 just to check it, right?
Okay.
And none of them will.
Because we don't have a case. It should go to the default. Just another day.
But it will go to the default for each one.
Yes, because we don't have any explicit case there.
That's stopping.
Exactly. So it just goes to the default. That was just to show what a switch
I just
is.
wanted to make sure I was, because I got just another date as many times.
Yeah, exactly. You could go into individual cases, which was Friday.
Okay.
What we did on Friday, we could also do there. So you could say from 0 to 45. Yeah, exactly. Okay, so do we all have the print statement 0, 1, 2, 3, 4? Right? Do we?
Yeah.
Okay, great. So now we want to change this for statement and use a range to print out this message. So we need to ignore the variable because we're not using any variable. And we just say print message here. Let's run our playground. So now we have Happy Monday iOS 5 times. We ignore the variable name. We are not using a variable name in the print message. Everybody with me?
No.
Okay.
Why do we have to lock this word in? I mean, like 0 to.
0 to 4, in that case, is saying arrange. Print this message 5 times. So the for loop goes through the range 0. Every time the statement goes through the for loop, the 0 gets incremented. So the first time, let's put some notes here. First time it is 0, right? Next time it is 1. Next time it is 2. Next time it is 3. To ignore the variable name. Yeah. Because we, like in fellows, we use the fellow variable name, correct? But here we're not using a variable name in the for statement. So we ignored it with the underscore. So next time it is 4. So at this case here, do we go to 5?
No.
No, right? Because this is a half range. We do not include 5. Every time you enter the for loop, that number here gets incremented. It starts out at 0. Next time it goes to 1. Next time it goes to 2. Next time it goes to 3. Next time it goes to 4. It looks at the condition. Is 5 included? No. So it exits, and the for loop is done. Okay? So we have 5 print statements. Happy Monday, iOS 6.3. If we want to include 5, we will just put in a dot instead of the less than sign. And now, how many times will it get printed? 6 times. Thank you. Right? So here we have 6. Excellent. So this, the 3 dots is inclusive. Remember earlier we showed? So 1, 2, 3 is inclusive. 1, 2 less than sign, exclusive. Exclude, right? Exclude, include. Exactly. Exactly. So Amini's question, statement is very true. Amini, can you say it again, please?
So to use the underscore in replacement of the variable and not using it.
Yes. So in the back, Amini is saying the underscore is being used here because we are not explicitly using any variable name inside the for loop. Everybody sees that? If we do have a variable name here, num, the compiler will give us a warning. You are not using num. Here, that yellow warning here in the box, the yellow box warning. It also gives you an ability to fix it by clicking on that fix button here. If you fix it, the compiler automatically removes the num, replaces it with an underscore. Do not submit code with warnings. You'll get feedback for this. If you do this and you submit it, IA's instructors will give you feedback. You are not using the variable. Please use an underscore. Never ever submit code to an employer that looks like this. Yes?
We're not using the num in the message.
We're not using num in that open curly and the close curly. We're not using it anywhere here. The num keyword, the num variable name is not used here.
So we use it, say, like an else statement. I don't understand.
In our use case, we only want to print Happy Monday iOS 6.3 5 times, right? We only interested in saying, hey, go ahead, I want to print it for 5 times. You were given a question. The question said, print Happy Monday iOS 6.3 5 times using a for loop. You go ahead, you use your for loop, and you said, I want to only print it 5 times. So you said, you created a range, 0, not including 5, run the loop 5 times. That's what this says. This says, run the loop how many times? And each time, print message. That's what the loop is saying. You want to explain it to somebody? That's what you say. This loop is looping over a sequence 5 times, and it prints the message, Happy Monday, iOS 6.3. Right? So a prompt or typical question would be, so question, use a for loop to print the message variable 5 times. Right? So that would be your answer. Excluding the num here, because we're not using num, as we said before. You're not using it, you use an underscore. If you were using it, you would use an underscore. For example, if you want to use num to show what message, what number you're on, you could simply say num here. Right? Here we're using num, correct? We agree? I'm using num, and if I run my playground, 0 message, 1 message, 2 message, 3 message, and so on. Everybody with me? Okay, so let's go back to show where we're not using it and what it looks like.
Oh,
Oh, I like the O factor.
If you're not using the four, like whatever words you're putting after your print, whatever variable you're using, once you're not including it in the print statement, then it's okay.
It's good. It's good. Very good. Okay. Any other questions before we continue? What's that? Scroll up to which one? To this one? Okay, cool.
And then
Really? No, right? You good? All right. Yes, Kabi.
Should we get in the habit of using that as instead of like one dot dot dot? Like say if you want to run a program X amount of times, you want us to use.
In that case, the question is asking use a for loop to print the message variable 5 times, right?
So I mean,
So-
for
This one is valid. You could also say 1 dot dot to 6, right? It depends on what you want to do, but this is fine. As far as that, we're not gonna give you any like feedback to fix 1 dot dot as opposed to 0 dot dot. Okay? It depends on the context of the question. Okay, let's see what the while loops. Before we do while, actually, before we do while, let's see what control transfer statements look like. So let's create a new heading here. Control, yes,
can you go into it because
sure. Control transfer.
okay, so
Uh,
when you print statement using the variable,
What line? What line you want me to go to?
basically right there. So let's say if we did for num, let's say we did add a variable in there, right?
Mm-hmm.
So if we did add for num in 0, you know,
If we did for num,
yeah,
okay,
and
and in the print statement,
and then in the print we put num, comma, and then the string interpolation. That has to be in quotes.
and what a string interpolation needs to be in quotes, yes.
So that would have to be in quotes, but none does not. It still will recognize none. But if you loop it, it'll increment.
Yeah, it increments. Every time it goes through that loop, it increments by 1. So the first time it's 0, second time it's 1, and so forth, until it gets to 4.
So that right after it says how many times to repeat it, but then you put number, then it'll say repeat this many times, I'll put a number each time that.
The number itself increases each time because we started the number at 0. If you started the number,
We did it 1 through 10, only we're adding a message behind each number, and on each line it's a new number, it's a new line.
exactly. So you could start the number with 2, you could start the number with 3, whatever number you want.
And if you would have put Terminator, it would be on one line where on
Yes.
one line it's saying 0 message, 1 message, 2 message.
Exactly, exactly. Very good. Good clarification there. Any other questions? Good questions are coming. Okay, so num is gone. We're not using num here. Let's go down to transfer control. Okay, so the transfer controls we'll be talking about here. We'll talk about break, continue, and where. Just put this here, transfer. Put that here. Okay, control transfer statement, what does that mean? Well, we have our loop, we have our for loop. In that case, we haven't seen the while loop. But you have a for loop, and at some point, maybe you want to have a condition where if you find the thing you're looking for, you no longer want to loop, right? You no longer want to continue through the loop. You want to break, right? Or you want to continue to the next number. Or you want to have a condition to only look for even numbers, right? There's different ways to add flexibility and more functionality onto the loop statement itself. So those 3 control transfer statements we have there, where, break, continue. We also have return, throw. We're not going to show now, but we'll just show those 3. They enable us to get out of the loop if some condition is met. If it's Joshua, get out of the loop. That's who we're looking for. We're looking for Joshua. We find him, break. Okay? Let's see what where looks like first, and then we'll continue. Okay, great. So we'll start out for number in some range or something, some collection, some sequence. This has to be a sequence. Whatever is coming after in should be a sequence collection. So here we have 1, 100. This is inclusive. It includes all the numbers, 1 to 100. The question asks, use where to print only numbers ending in 5, for example, inclusively. That's your question? What's that? Oh, yes, okay. And this is question, right? Cool. So far, so good. We've seen for the keyword. Number is a variable. In is required to say what we're going in. What are we looking in? We're looking in some collection, some sequence, some range. Here the range is 1 to 100, including 100. So we say inclusively. So far, so good? Okay. Now we'll see where. Because the question asks only print. Only here. Only print if that number ends in 5. Right? Only if that number ends in 5. If you see 15, print 15. You see 5, print 5. You see 8, are we printing 8? No. We see 25, are we printing 25? We see 105, are we printing 105? We're no longer in 105, right? Okay. All right. Lunch is coming up. Yes, where is adding a compound statement onto the loop. So here we have where number mod. We remember mod, right? The remainder. Tanya said equal 5. I think that's what I heard you said, right? Maybe. That's what you said. I heard you. Sorry, not 2 equal sign, 1 equal sign. No, 2 equal sign. What am I doing? Okay, so here we have for number in 1 to 100, where number mod 10 equal to 5. Right? A lot of things to write here, but it gets us what we want. Forget about the where for now, right? Take this out of the equation. Do we understand the for number in 1 to 100? Yes. So now we add in this control transfer statement where some condition. You could add conditions onto the for loop. Here we add in an additional condition, like we had a condition earlier with the if else, correct? And we had the switch. Yes?
And this is basically what we said before, that when it's the last digit of the number, we have to put mod with 10.
Yes, exactly. So here we're taking the remainder of that number. Okay? Some number divided by 10. If the remainder is 5, add it. Everybody with me? Okay? 15 mod 10, remainder 5, add it. 3, no. 25, yes. Okay? Right? So we have 25 mod 10. What's the remainder? Are we adding 25? So we're going through that from 1 to 100. That's where the power of the computer comes in. Can you imagine doing that 100 times? Not really. But the computer is our friend. It does it in the speed of a second. Okay, awesome. So now we are using number variable. We could have a print statement saying number ends in that satisfies that where clause. Each number that satisfies that it will print. So
So there would be that print, that message would be behind it.
that message will be, that message only gets printed for numbers that ends in 5.
Right. So
5, right, 15, and so forth.
Yeah, that's what I'm
Yeah, very good. So here we have our number variable, ends in 5, or last digit is 5. Right? So let's go ahead and play our playground. And let me pull up that console here. Okay, so let's see. So we started from the number 5. 5, let's put a there in there. 5 or 5s. I need to read a little better. Let's play this again. Okay. So 5's last digit is 5. 15's last digit is 5. Do we all see that? Right? Up to 95. So it does go through the sequence. It does the mod operator. If the remainder is 5, it includes it, meaning it prints it. If it's not, it doesn't go inside the print statement. Did we all get our console looking like this? Right? So you could get a question, hey, print only my even numbers. Print only odd numbers. Print numbers that ends in 3. Do we see the picture there? So this is very powerful, right? And we'll get used to it in the lab. Yes.
So, what type of, because we can do the same thing where
You could do if statements, yes. Yes. Yes, you could do if statements as one is bringing up. But as I said, with programming, you have different ways to do things. As we see, we have one line here. It may look a bit verbose on one line, but that one line captures that for us. But yes, you could have an if statement inside the for loop as well, opposed to this. Yeah. Cool. So this is the where. Let's see what break looks like. It would be perfect to do break with what we had earlier. Okay, that's fine. Let's do break. So this is where here. What's that? Say that again, sorry. I was gonna do it with the fellows, but I don't want to go back up. Yeah. So I'll just create a different for. We'll look for something else. So let's use break. So break basically says, you find something, get out of the loop. No longer you run in that loop. Break, get out, you're done. Okay? That's what break implies. Exit loop. Or end loop. Stop looping. All those things, right? So let's go through a sequence of numbers for num in 1 to 50, for example. Here I'll say if num equal to 40, print you found me. Actually, let's do this differently since it's my son's birthday today. So if num equals to 7, happy birthday. Nice, right? And you found it, now you want to break. And let's prove that we broke, right? So otherwise, else, print not your birthday yet. Okay, so we have a for loop here. It's looping over numbers from 1 to 50. It's using the if statement to compare some number. It's saying if number equal to 7, go inside the if statement, go inside of 91, print happy birthday Miles, and break, exit. Exit the for loop here. So exit. So the minute it comes to the break, it exits that for loop. Nothing else runs. Let's make that number smaller so it's not clogging up our console. So now we'll run. Right? Not your birthday, not your birthday, not your birthday. Last statement is happy birthday, Miles. It exits the for loop, and that's it. We're done. We found what we were looking for. Right? So not your birthday, Miles. You're only whatever old. You could put num in here. Let's run it again for more context here. Did I print it? Did I run it? Da, 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 da. Well, I put it in the wrong place. Sorry. You guys are correcting me here. I got candy. I got everything. Now I wanted to like, if it's not your birthday yet, you're only. That's what I wanted to do here. This. So not your birthday.
Yeah, it's going to say you're only 1 year old and 3 year old.
Exactly. So let's see what happens. We had it in the wrong place. So now, it's not your birthday yet. You're only 1, you're only 2, you're only 3, you're only 4, 5, 6. It gets to 7. It prints happy birthday, and it exits. Everybody with me? If it's over those ages, this is not what we are looking for. So as we see, the loop should have gone through 1 to 10, correct? But we are using break, the break keyword, to break out of the loop the minute we find what we're looking for. We found what we were looking for when it was 7. It was 7, we found what we were looking for, we went inside the if statement, we printed happy birthday Miles, we exited the loop, and we do not print anything else. Because the last line in our console is number 7, correct? So this is the power of a break. Break is awesome, it's great. Whenever you're searching for something, you could use the break statement. You found what you're looking for, break. No longer loop. No longer look for stuff. It's like Google. You type something in, it finds it, boom, you got your thing. Yes?
Where is when something is found, like,
Yeah, in that case, we are using it. We're not doing anything great here, but we're using it by saying happy birthday, Miles. We could give him balloons if we want, right? We use where up here. Where is more like something specific. Exactly. Like you want to only show even numbers. Yeah, exactly. And the break is you found something. Yeah, something specific. Yeah.
So when you put it to 10, because you broke, or because you break,
Uh-huh.
and after 7 it didn't stop, as opposed to if you did it for break, it would still go to
Yes,
8,
so
9, 10.
exactly. So if we comment out break, what happens? Will it stop at happy birthday Miles? No, it's going to continue until when it gets to 10. Everybody with me? All right, very good. Okay, let's see, continue. Continue is different from break in the fact that it will continue to the next number. It sees a condition, it continues to the next number, as opposed to break it, right? So if something is true, continue to the next number. Let's see what that looks like. So for num in, we'll use that same thing we used earlier here. For num in 1 through 10, if num mod 2, for example, is even, continue. Right? So if it's even, continue. Here, just print num. So if it's even, we're not interested in that number. Num mod 2 equal to 0 says even, right? So even numbers. Yes? The print is outside the bracket because what happens, let's walk through what happens here. So if this condition is true, everybody, continue to the next number. Increment, let's comment it out. So increment means add. So increment, add, right? So increment to next value. Example, if current value is 1. No, 2. If current value is 2, right? 2 mod 2 is what? 2 mod 2 is 0, right? Everybody? 2 divided by 2, remainder? That's all the mod means. Mod means give me the remainder. 2 mod 2 is 0. Right? So 2 mod 2 or 2 mod 2 is 0. Everybody with me? The percent sign is called mod or modulo. Right? Mod or modulo. Modulo operator. Remainder. Thank you. Remainder. Right? Modulo operator, remainder operator, mod for short. But basically, if my current value is 2, okay, I come in here, it's 2, it passes the condition, it's even. What I do is I increment to the next value. What's next value if I increment? 3, right? We all see that? Right? Yuba? We increment, we add. If it's 2, it becomes 3. If it's 5, it becomes? If it's 5, it becomes? If we decrement 7, what's the answer? If we decrement 5, what's the answer? If we decrement 0, what's the answer? Other people in the back. Matri. If we decrement -1, what do we have? Okay, everybody? Decrement means subtract 1. Increment means add 1. What the loop does, every time the loop gets run, meaning every time I enter this for loop, if my current value is 1, I go inside my for loop, I get to the end, I get to line 108, right? I increment, the number now is 2, meaning I get to the end of the for loop, I continue my for loop, I add, so it becomes 2. Decrement is, yes, exactly. So every time I go through my for loop, top down, I have to run my entire for loop, meaning I have to go through lines 100 through 108. That's the entirety of the for loop. When I get to that bracket here, I'm at the end of the for loop. The for loop checks for the condition again. Am I still in the range 1 to 10? If I'm at 2, I'm still in the range. It comes in here. Is 2 mod 2 equal to 0? Yes. Comes in here. It continues. Continue means do not do anything else. Do not continue to this print statement. Increment, go to the next value. That's what continue says. Very similar to break in that instance. They're very powerful, but here, instead of breaking and not continuing the loop, it continues to the next value. Continue, right? Continue to the next value.
So it basically goes to all the values, doesn't go to print until all the values are met.
It will go to print if this is false. If this is odd, will it come inside the if statement?
No. So let's skip.
Everybody, if this statement is false, does it come inside the if statement? Where does it go? In the back, where does it go? To print, right? Jahid, if the if statement here is false, where does it go? To the print, right? It's false, it doesn't enter the if statement. It's going to print that value. In that case, what does it print here? An odd value, correct? So let's go ahead and run our playground. Angel got his wings. I'm sorry? Fall through goes to the next case. Continue here in the context of a loop goes to the next value. So if my current value is 1, or in our case, if it's 2, it should be even. If it's 2, it does not print. It does not get to the print statement. It continues to 3. If it's 4, right? 4 is even, correct? It continues to 5. Continues to 6, 7, 8, 9, 10 until it's done. Well, it prints the odd numbers, but for any even number that comes up, it continues to the next number. Yeah, exactly. So that's a good, yeah, exactly. So as Steph is saying, in our case here, it skips the even numbers and only prints the odd numbers. So far, so good? Were your playground able to play? You guys saw the outcome?
Yeah.
Mine is, question, sorry, Emily, go ahead.
I just want to know, just for like, being able to reference it, what would we consider I think I read calling it sequence, like,
The dot dot,
yeah,
it's a range,
that's a range, but what about
the fellows.
yeah, like that's an
The fellows is an array, but the whole point is whether it be a sequence, a range, a collection, it's a collection of items.
So like if we're saying, it's gonna continue to the next value of the range.
In that case, I would say the next value of the range is fine, or the numbers is fine. Yeah. Okay. Yes, question.
So like continue basically increments the f one to how do you decrement like how does that
So we'll see later when we talk about arrays, like I'll go into arrays and we'll see like strides, how to reverse, how to go backwards. But for now, the loop by nature, by its default nature, it always increments to the next value, right? So you have a set of fellows or whatever, or numbers, it goes from that sequence of numbers, from a lower range to an upper range in that set. So A, B, C, D in that case, okay? But arrays will see more about going backwards. Like, hey, I have a set, I want to go back from the top down. Yuba? Does that answer your question? Okay. Yes. So as Yuba is bringing up, very good. Continue, you could always also read as skip. Everybody with me? Right? So continue, skip. Skip to the next value. Maybe you post that to Swift, huh? Tell them, hey, change this, continue to skip. But yes, also, yes. Fancy Terminators. You hooked on Terminators. Antonio, is it possible to take Terminator? Our Terminator is terminated. Okay, how are we doing so far? So we've seen break, where, and continue. Let's see what the while loop looks like. Everything you do in the for loop, you could do in a while loop. So we're not going to go through like the switch and the if, because we could also do it in that while loop. So far, so good? Okay. So we'll do the while loop, and we've seen the repeat, but we'll still do the repeat. And we will close out, okay. Okay, so let's see what the while loop looks like. I will go ahead and just grab one of my headers here. Go down to my while loop. And this is while. Exactly, exactly. So as Zara is saying, while implies while some condition is true. While some condition is true, go ahead inside my while statement, execute my commands. Let's see what the while looks like. And again, the while, the only difference here is, as we see later in the program, we use the while, especially when the sequence is not iterable, we could use while on it. But for now, just think of while as a different way to write a for loop. Okay? Later, we'll see use cases, when and how we use it. But you'll catch yourself writing for loops more. For loops are more frequent in Swift. Easier to write, very quick. So while, let's start out with a variable. So here we'll have seconds. We have a variable seconds. We start off at 30. And here we say while seconds is greater than or equal to 0. We've seen comparison statements again. Here, seconds is greater than or equal to 30. Currently, is seconds greater than or equal to 0? Is seconds greater than or equal to 0?
Yes.
Okay, perfect. Do we come inside the while statement?
Yes.
Yes, we do. So, we come in. We have a print statement. And we say countdown. And we could put in some value here, which is the number, seconds. And very important, I'm not going to have you guys do it on your computer, but be careful. If you do not forget to decrement here, you'll run in what's known as an infinite loop. Because right now, imagine, let's go through the code. Seconds equals to 30, while seconds is more than 0, print. Does this ever stop?
No.
I want to make sure we all see that.
So the forward punch is stopping.
That's just a print. The dots here is only part of the string. It has nothing to do with what's stopping it. The what's stopping it is what we'll add now. Okay? So we need some sort of condition here. It's just like part of this, the string, like countdown. Like countdown doesn't do anything. It just like shows a message. So the dot in that case, I know like you maybe have it a little bit with the range. Yeah, but it's not with the range. It's just a string. Anytime you see like red here, it's just part of the string. So it doesn't affect the code. Does that make sense? All right, very good. Like I could put a smiley face in here. It's not really gonna, yeah, very good. Exactly. But what affects code is like this part. Exactly. So countdown, seconds, whatever the second says. While condition, let's refactor this. While condition needs a way to stop the loop, or it will run infinitely, forever, until your playground explodes. I like that. Explodes. Runs out of resource, right? Eventually, the computer itself might even crash depending on how much memory you have or whatever. But we all agree we need a condition here somehow to make that stop at some point. What are we going to do? How can we make that condition stop? Or get smaller, for a lack of a better word. Get smaller. We are 30 seconds. We're counting down. If we're counting down from 30, what's the next number? 29. How do we get to 29? Decrement, right? So we're going to decrement seconds by what? 1, right? So here we are decrementing seconds by 1. We're decrementing seconds by 1. So currently it's 30. When it gets to line 121, what is the value? 29. It goes back to the while loop. It goes back to the while loop. It checks the condition again. Is 29 greater than or equal to 0? What happens? I come inside my while loop, correct? I decrement, 29 becomes 28. I hit my closing bracket. I go back up to my while loop. 28, is it greater than or equal to 0? So I keep going until when that condition is met. Okay? When that condition is met, I'm done. Let's go ahead and run. Right? Darn quicker than I said anything. So if we go to the top, we have countdown 30, 29, 28, and so forth, until we get to rocket launch. Do we see that? Yes.
That's why you have to make it negative for it to go the opposite way, because it's not that per second. If you just leave it without seconds,
It will run, it's going to be an infinite loop.
32, 33, like that.
If you do not do anything, you do not increment, decrement, it will be what's called an infinite loop, right? If you do not have this part here, let's put some notes here. So without this, without decrementing seconds, the while what's known as an infinite loop, right? When you have infinite loops, actually Apple's campus is called one infinite loop. So, well, infinite, indefinite, infinite, indefinite, infinite loop. If you do not have that condition here, I do not challenge you to do it. But if you were to comment this out, your playgrounds will stop running at some point. After it's ran like 30, 30, 30, 30, 30, after a while, your memory, your RAM, right? Your RAM will just run out of resources. The 8 gigs of RAM we have, at some point, it's just going to stop. So, anytime you have a while loop, and this is very important, the difference between the while here and the for, we didn't have to do this in the for loop, correct? The for loop is powerful enough to know how many contents it has, right? Either we have a fellows, like a fellow in fellows, we saw, or we have a range, right? But at no point did we have to explicitly say, hey, go ahead, go up or down, right? Do you remember from the for loop? All what we said is for fellow in fellows, print fellow. The for loop iterates, it takes care of the stopping. The stopping part of it, it takes care of this. So when it gets to the last element, it's done. Everybody with me? That's one of the inherent differences between the while and the for, right? The while, you have to take care of this. Very important. If you don't, you'll run into an infinite loop. So whenever you're looking at some question that asks, determine what happens in this while loop, really look for how does it stop? How does that while loop come to a stop? How do I exit from that while loop? So look for like line 124. Look for that case there. Yes, Luba? I'm inside of the while loop. Okay. Like in here? Up here. Oh, like a range here? In our case, we could have some range, but here we have seconds. Seconds is the variable, and we want to count down. The point of this, the point of this is to we have a rocket launch or whatever we have, so we're counting down 30, 29, and 28, rocket launch. And we could have an if statement here saying something else. I'll do one if statement, and okay, let's just see what an if statement looks like over here. So if seconds, for example, equal to 0, we will do something here, else we'll do something else. So if seconds equals to 0, countdown, here we could just launch our rocket, right? So here we could just launch our rocket, else we're doing the countdown, and let's see what that looks like. Right, so we have our countdown. Let me just show the code up here so we all see. So we have the countdown. When it gets to 0, our rocket is going up to space. Everybody with me? So we have an if-else in the while. Remember, we could compound our statements. This is a compound statement. We have a while. Inside the while, we have an if-else. So if seconds equal to 0, meaning we're on the last second, launch the rocket. We're done. Else, continue the countdown. Everybody sees that if-else? Any questions? Luba, walk me through the code. How are we looking at? What's happening with that while statement? Okay. Okay. Exactly. Everybody with Luba here? So it comes in the while statement because this statement here is true. This statement, seconds more than equal to 0, is true. Why is it true? Because seconds is 30. 30 is more than or equal to 0. So come inside my while loop. When I'm at 30, am I going to come in seconds, launch my rocket? No, because 30 is not equal to 0. So I come inside my else statement, and I print 30. I print countdown 30 seconds. 30, 29, 28, 27, 1, 0, boom, rocket launch. At the bottom, we do. If we do not have it, we will have an infinite loop. That decrement is very important. It's the way we stop the while loop.
Wait, so this,
Yes.
the decrementation happens after the print?
Yeah, after the print, like the last statement we did in the while loop. Yes.
I'm just not understanding why that alone stops the while. Like, even if you do.
Okay. It stops it. Let's walk through it. It stops it because first time we at 30, right? So we decrement, it's 29, correct?
Right.
Next time we are 28.
Right. No, I get what it's doing, right? And
So the minute it gets to, wait for it, if we add 0 here, it comes up, 0 is equal to 0, correct? So it still comes into the while loop,
Right.
correct? I decrement 0, what is this? Minus 1.
It's gonna say that's not part of it.
So minus 1, let's go back up. So minus 1, I go back to my while loop. Is minus 1 greater than or equal to 0?
No.
Right? So I'm not coming in my while loop. So here, minus 1 is not equal to, is not greater or equal to 0. Everybody sees that? Does everybody see that? When I get to minus 1, I do not come in the while statement. My program is done.
So now, what is
Yes, Christian.
So I was following up with what you're doing, and then at some point,
We will be slacking out the code.
my rocket
We'll be your rocket. Yeah, your rocket will ship. All right. It's gonna go up. It's gonna go up. Yeah, it's gonna go up. Yes.
So when it's the other way around, you would have to have a patent number. Like you could go just the other way around in your increase.
Yeah, we decrement here because we want to get to 0. If you want to get to a target number, you would increment.
Okay. But
Okay?
You have to set a target.
You have to set some sort of target, and you must have a way to stop it.
Okay.
Yes. Any other questions? We'll wrap up loops. We'll continue loops tomorrow, where we talk about the repeat while. Repeat while we saw already. So you have enough context to basically do your lab. Tomorrow we'll talk about repeat while, and we'll talk about labels in loops. So if you have any questions with that, we're here today to help. But as far as the content of what we need today to do our labs, we have it. Cool? Awesome.